Alright, so we'll go on and look at this tutorial sheet number 6. Practice questions on binomial expansions to start with. Yes, so use the binomial theorem to find the values of the following 1.0001. Maybe I just want to give you the questions that we are looking at so that you just know the questions that are in this tutorial sheet. So these are the questions that are here. Okay, these are the questions specifically under binomial. The other videos will be, the other questions are covered in the next video, part 2. Look for part 2. The ones that are from calculus limits. Okay, so we'll proceed. You understand that this is the second part of the tutorial sheet. This is 6th. The previous one also dealt with a bit of introductory to binomial, but I want to now look at these. Okay, so whenever you look at finding square root under the binomial expansions, we apply this simplified form of a binomial theorem, where we say that if you've got 1 added to x, okay, raised to the power n, of course, where x is less than 1, such an expansion, and usually this is necessary where we're working with n, which is of course negative or a fraction. When not x x shouldn't be greater than 1, but instead x should be less than 1. Okay, the simplified form of the equation is 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 3 factorial x to the power 3. This is the equation that we'll use for such expansions. Okay, now looking at the one that is at hand, we have the square root of that. So square root is the same as the power half. 1.001 raised to the power half. Now we have to express it in terms of addition. So that is 1 plus 0.001 raised to the power half. And so from there it becomes easy. So now I will just go up to the second term, to the third term. That's enough. You'll be able to see why. Let's try to substitute. So our value of n is half in this case. So we have 1 plus half, and then our value of x is 0.001. Okay, if you want you can take that into a fraction, but I'll take it as it is, plus our n is half, again half minus 1, I'm just substituting there, divided by 2 factorial, and then we've got x squared, which is of course 0.001 squared. 1. Now you ask yourself a question: what is the half of 0.01? What's the half of it? So the way you can use it, think of this whenever you've got such a number. When you think of 0.1, it will give you a hint. The half of 0.1 is 0.05. Just add a 0 where there's a 1, and the next add 5. 5 plus 5 will give us a 1 there. So equally, here the half of 0.01 is going to be 0.0005. That's the half of it. Okay, so that would be plus 0.0. We'll introduce an extra 0 and then add a 5. Plus half minus 1 gives us negative half. Okay, so we have half multiplied by negative half. Now dividing by 2 is the same as multiplying by 1 over 2. And then that squared, just count the number of zeros and double them. So we have 3 of them. So they now become 6 of them. So that would be 1, 2, 3, 4, 5, 6. Since it's a 1 at the end. If you want, you can go on and multiply, of course. 0.001 multiplied by 0.001 and do all, and then count the number of decimal places, which should be 1, 2, 3, 1, 2, 3, 6. Okay, Okay, so how do you proceed from this point? Is there anything that needs simplification? Of course, this part. So that's going to be a negative. Negative 2 times 2 times 2, that's 8. 1 over 8. And then we have 0 0.0000001. Okay. And then we have 1 plus 0.005. Okay, so now at this point the basics of binomial are already used up, and all we just need to now is apply our basic mathematics to simplify the questions at hand. Now 1 over 8, this can be easier if you take it in terms of multiplications, right? Take this into a decimal, 1 over 8 into a decimal. To be easy to deal with decimals than deal with a fraction and decimal. Remember, I'm assuming calculators are not allowed. So 1 divided by 8, 8 into 1, we can't divide that, so we introduce a 0. Okay, and then into 10, that's 1, and then remain with a remainder of 2. Into 2 we can't, so we add a 0. That gives us 2 times. That's of course a 16, so a difference of a 4 again. Into 4 we can't, so add a 0. 40, that's a 5. So 0.125 is the value that can represent 1 over 8. 0.125. Now 0.125 can easily be multiplied with 0.001. I can show you how. So we have 0.00, how many zeros have we? 5. Multiplied by, what do we have? That's a 0.0125, right? 0. So we'll just take it at the end. So we have 5, we have 2, we have 1, and then 0.0. So basically when you're multiplying, you ignore the decimal places and then you come and count them at the end of it all. 5 times 1 is a 5. 5 times the 6 zeros, that would just be 6 zeros. How many of these 5? 6. The next number is 2, and then 6 zeros. The next number is a 1, and then 6 zeros. Next number is a 0, which of course will just introduce all unnecessary zeros, eh? So we don't need them. So we have 5, 2, 1. Now decimal places, this is now where we've wasted a lot of time. We could have just looked at 0.125 and would have moved just the number of decimal places. So that's all we needed. So how many are there? So 1, 2, 3, and then here we have 1, 2, 3, 4, 5, 6. 6 plus 3, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. How many zeros have we put? 1, 2, 3, 4, 5, 6. So 6 zeros. 1, 2, 3, 4, 5, 6. So 0 point, and then 1, 2, 5 at the end. If you want, you can use a calculator to prove that. Okay? 0 point over zeros, 1 multiplied by 0.125. So you find that it's going to be that with all these zeros. Okay? How many zeros are they? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Remember, it's 9 decimal places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need one more 0. Okay, so 7 zeros there. So you've now learned a shortcut. So every time you're trying to perform all that multiplication, you don't need to go that far. Just as long as there's a 1 at the end, you just count the number of decimal places and then add the numbers that are there at the end. So that's what we have. Now this is only for this part. Okay, so we now have 1 plus 0.005, which of course we can add, can give us something we can easily deal with. So we have 1.005, because 0 plus the 1 gives us a 1, and then we're subtracting the 0 point. Remember these zeros were 7. Okay, so we just subtract these two numbers and then you'll be able to, so you're able to subtract, I believe. In case you've forgotten and you've got all the time in your assessment to subtract, so here now you write according to the decimal places, just like we did in the previous one, but here the difference is the way you find the answer, that's the way the answer will remain. Okay, to just zeros, unlike the previous one where we were counting the decimal places at the end. So you can now subtract. Okay, so I'll leave that to you. But when you subtract, you should get something like 1.000499875. How do you start? You can't subtract a 5 from a 0, so obviously that will remain a 4. 9, 9, 9, 9, 10. That's a 5. That's a 7. That's an 8, 9, 9, 4, 0, 0, 0, 1. That's where that value is coming from. So I had to take all these minutes just to show you how you can handle this. Now that I've shown you a practical example, now you can go about all these complexities. The next ones I'll just try to rush into them and just use the calculator to manipulate them for faster simplifications. Okay, so here we have 1 divided by that. How does that look? What does that mean? So you can actually present that as to be 1.02. Now that we've made this a numerator, it implies 2 will be raised to the power -2. And of course what it implies is the one that is on top is still there, but there's no need of us to show it, unless if we had a number like a 2, it would have remained. Okay, so that's what you do when you've got a fraction. Now we can take it again in the form of 1 plus a value that is less than 1, which in this case will be 0.02. Now don't forget our formula that we're dealing with, that is was 1 plus nx plus n minus 1 over 2 factorial x squared, and so on and so forth. So plug in our values. I just want to make sure we did 6 decimal places for this question. Are they 6? So let's just try to count. So 1, 2, 3, 4, 5, 6. You can cut from this point. 1.0004999. Now if you add a 1, it brings some issues, huh? So it becomes a 0, then it becomes a 0, then it becomes a 5, 0, 0, 0.1, something like that. Yeah, so how do we proceed from here? We have 1 plus, our value of n in this case is a -2, so we have -2. Our x is this part, that's 0.02, negative 2, negative 2 minus 1 over 2 factorial. X squared is 0.02 squared. You can proceed if you want. If you're using a calculator, especially, you would want to proceed to the next term. That would obviously be n minus 1, n minus 2. Now here to be 3 factorial, and then x to the power 3. So practically what happens is, if you've noticed a trend, these first two are already part of the previous term. So that would be negative 2 multiplied by negative 3, which would be positive 6, multiplied by n minus 2, which is negative 2 minus 2, and then x to the power 3, our x is 0.02. The power 3, over 3 factorial. So we have 1 minus 0.04. Negative 2 times negative 3 is a negative 6, divided by 2. This is actually a positive 6, divided by 2 on the bottom. 2 factorial is 2 times 1 is just 2. So that gives us just a positive 3. Now 0.02 squared. 0.02 squared gives us 0.0004. Okay. Plus, now negative 2 minus 2 is a minus 4 times the 6, gives us a negative 4 times 6 is what? 24. So negative 24. 3 factorial is 3 times 2 times 1, which is like a 6. And then don't forget we have 0.02 raised to the power 3, which is 0.0000. How many zeros are there? That should be 5 of them. Okay. Now at that point, that value is supposed to be divided by 6, multiplied by negative 24, added to 3 times 0.004, and then minus 0.04 plus a 1. So the value I'm getting is 0.961168. How many decimal places are these? 1, 2, 3, 4, 5, 6. So that becomes our answer in such a case. Now, is that true? What if we got our calculator and tried it out on the calculator directory? So 1.02 squared is something like 1.0404. Now 1 divided by that. So the value I'm getting is 0.96116878. So you can see that it's actually close to the accurate value by using binomial expansions. So that's what binomial expansions can do. It can simplify these expressions. Okay. So in a case where you don't have the calculator, you can still use binomial to manipulate all that, and that proves that binomial is actually accurate. Now when you look at this one, the third one, feel free to pause the video. Whenever you look at the square root, we say this converts to half as a power. Now in dealing with a third root, what that implies is it's the third root 1 over 3, which we can express as 1 plus 0.03, and you can easily manipulate it from this point. How? Don't forget our formula, 1 plus nx plus nn minus 1 2 factorial x squared plus same trend. Now introduce an extra term, it becomes 3 factorial plus. If you're having issues remembering this formula, watch our introduction video. I explained on how you can easily remember this formula. Okay, let's proceed now. our n in this case is 1 over 3, our x is 0.03 plus 1 over 3, 1 over 3 minus 1 over 2, 0.03 squared. So to ensure that the next part is easier, we can simplify this, which is already existing there. So 1 over 3 subtract a 1 is negative 2 over 3, right? Negative 2 over 3. So we have negative 2 over 3 for the first part, and then we have a 1 over 3 minus 2 divided by 3 factorial, which is just 3 times 2, which gives us a 6. And then x to the power 3, of course, that's 0.03 raised to the power 3. Now at this point, all you just need is just to grab your calculator and perform the required calculations. So I'll start 1 over 3 multiplied by 0.03. So we have 1 plus 0.01. The next part, 1 over 3 minus 1 is negative 2 over 3 times 1 over 3 divided by 2 multiplied by 0.03 squared. So that gives us negative 0.001. And then the last part, negative 2 over 3 multiplied by 1 over 3 minus 2. So I'll do this again. 1 over 3 minus 2 multiplied by negative 2 over 3 multiplied by 0.03 to the power 3 divided by 6 gives us 0.000005. And then we can add these parts as well. So we have a plus 1 plus 0.01 minus 0.001. So the value I'm getting is 1.009905. 6 decimal places should be. Okay, so for the sake of cases where calculator is not allowed, it's okay to end up to this point, and I believe you're able to manipulate all that to avoid complications of numbers such as that. Okay. Alright, so look at this interesting question. We've got like 3 of them that we just have to like handle from here. So I have to find the first 4 terms of expansions of the given. How do you go about it? So basically this involves you to apply the concepts of binomial expansions, okay? And we'll see how. So let's look at the simplest one, which is like the first one. For the first one, we have 1 plus x divided by 1 minus x. And for this one, the numerator, which is 1 plus x, can be multiplied by the denominator. The denominator can become the numerator by putting it in brackets, and then the power becomes a negative 1. That's all. Now from there, you will now have an idea of what you do there, right? You have an idea of what you can do. This remains as it is. Now we would have to expand this in a term that we're able to understand. Okay? Any idea on how we can expand that? Of course, you know. I already introduced you to these expansions. 1 plus nx plus n minus 1 to factorial x squared. So we'll apply that. Now they want the first 4 terms. It's simple. The first one is obviously going to be a constant. Then the rest will be the power x to the power 1, x to the power 2. So go all the way up to x to the power 3 for us to get the first 4 terms. So let's try to expand that. So we have 1. Let me just start from the end there. So we have 1 plus our n is -1. So let me just remove that. So -1 multiplied by x, x is -x, and then plus our n again is -1, and then n minus 1, our n again is -1. So if we plug in -1 minus 1 there, let me just write it as it is. So -1 minus 1, and then our x is -x squared. Our denominator there is 2. So dividing by 2, I already said it's as good as multiplying by 1 over 2. Since 2 factorial is 2 times 1. Now we have the last term of our interest, which will be n minus 1 up to n minus 2 over 3 factorial, and then of course x to the power 3. So we have -1. For the second one, -1 minus 1 will be -2. That part, -1 minus 2 will be -3. And then 3 factorial is 3 times 2 times 1, which is a 6. That's as good as multiplying by 1 over 6. And then our x is -x raised to the power 3. So basically this is what this part is. So we'll just say plus plus because it's not complete. We can simplify it. So we have 1, that gives us plus x. In the brackets here we've got -2. So -1 times -2 is a +2. +2 divided by, let me just write that, +2, and then x squared, and then divided by the half there. -1 times -2 times that, both are 3 negatives, that will be a -6. We have 1 over 6 there, don't forget, and then this, that will be a -x as well, -x to the power 3 plus plus. So we have 1 plus x, these 2 will go, so you remain with x squared, and then you have a minus, negative times that negative gives us a positive. So equally there you end up with a positive, that positive x to the power 3 dot dot dot. And so that's all we have, and we can actually use that now to multiply with that part. So the first part is 1 plus x multiplied by 1 plus x squared plus x to the power 3. And so that's all we have there at that point. If we multiply by 1, you maintain, I'm starting by that one, so we maintain 1 plus x squared plus x to the power 3. When multiplied by x, that would be x, that would be x squared, that would be x to the power 3, that would be x to the power 4. So we're interested only in the first 3 terms, right? So we have 1 plus 2x plus 2x squared plus 2x to the power 3. These are the first 4 terms, and that's enough for expansion. So therefore, this is our final answer. Simple and straightforward. There's nothing more, nothing less. So the same idea can be applied to all the other questions that we have here. So it's just the idea of you trying to see how you can manipulate what's on the bottom especially. So we have x plus 2 for the second one. If we bring what's down to the top, 1 plus x will be to be raised to the power -2. How can we expand it? Don't forget our formula. and then plus n minus 1, n minus 2, 3 factorial, x to the power 3. Okay, so we have our n in this case is negative 2. That is our x. Our x is x. That one even becomes easier because x is x. So we just go direct. So we have 1 plus, our n is a minus 2, so that's negative 2x minus 2 for a second one. In the brackets, that would be a negative 3 over 2. X remains as it is. For the next one, it will be negative 2 again, negative 3, and then we have a new term, negative 2 minus 2, that's a minus 4, divided by 3 factorial is just a 6, x to the power 3. This one is straightforward. These two can divide. This can give us a positive 6, and then they can divide. So remain with 1 minus 2x. Negative times negative gives us a positive x squared. This is a positive times that negative, it becomes a negative, so that would be a negative 4x to the power 3. So hopefully our manipulations are right. Then we expect of x plus 2 multiplied by 1 minus 2x plus x squared minus 4x to the power 3. We are not done. We can expand as many terms as we want, but we went there. Okay, because this gives us, we're interested in the first 4 terms. X times 1 gives us if you multiply by x, you're going to have x minus 2x squared plus x to the power 3 minus 4x to the power 4. Multiply by 2. 2 times 1, that would be a 2. 2 times negative 2x, that's a minus 4x. That's a 2x squared. That's a minus 8x to the power 3. That's where we are ending there. I'm just trying to ensure that I'm trying to make your addition of their like terms easier and faster. So we have 2, and then that's a minus 3x. That's a 0. This is a 0 clearly, as I can see. And then x to the power 3 plus that's going to be a minus 7x to the power 3. Okay, and if you are to look at this term x to the power 4, what's a possible source? There can be a next one there. Since we've ended at this point, are you able to guess the next one? I can guess the next one, so that we can just add it. Since we have a 0 somewhere there, the next one would be all the way up to n minus 3. So this part is negative 2. So we have negative 2, negative 3, negative 4. So now negative 2 minus 3, negative 5, divided by 4 factorial. 4 factorial is 4 times 3 times 4 times 3 times 2. And then of course x to the power 4. 4 can divide, remain with negative 1. This 6 can divide, remain a positive 1, since negative 2 times negative 3 is a positive 1. So negative 1 times negative 5 gives us a positive 5. So we have a positive 5 x to the power 4. And then 2 times that gives us 10 x to the power 4, which would give us plus 6x to the power 4. And so the first 4 terms would be 2 minus 3x minus 7x to the power 3 plus 6 to the power 4, 6x to the power 4, if all our manipulations are right. Basically, this is what you basically get to do when you're dealing with such questions. Now pause the video and try out the last one. We have 1 minus x multiplied by, so we have 1 plus x. Now 1 plus x to the square root is the same as the power half, so we can write that as 1 minus x over 1 plus x raised to the power 1 over 2. Now if we take it to the numerator, it becomes a negative power. So again, we'll start with by expanding this part. We have 1 plus our n is negative half in this case. That's what we make everything different. So negative half multiplied by our x, and then negative half minus 1. So now dividing by the 2 factorial is the same as multiplying by 1 over 2. For the next one as well, we'll have similar steps. That will be plus negative half. Now negative half minus 1, by now we should know that that's the same as negative 3 over 2. Now we also have an extra one, which is n minus 2. So that would be negative half minus 2, which is the same as negative 5 over 2. Right? And then we have x to the power 3. Don't forget that. Here I've forgotten, this is x to the power 2. So that will be x to the power 3. Divided by 3 factorial, which is as good as multiplying by 1 over 6. Since 3 factorial is 3 times 2. So we'll just end at that term. So we have 1 minus half x. This is negative half minus 1 is the same as negative 3 over 2, which will give us positive 6. If you multiply by with this, no, on top negative, so that will be a positive 3 on top. The bottom it will be a 4. We're still multiplying by another half there, x squared. Negative half times that will be a positive 3 over 4. Multiplied by negative 5 over 2, multiplied by 1 over 6, multiplied by x to the power 3. 3 there it's 1, 3 there it's 2. We have 1 minus half x. That would be a 3 over 8 x squared. 1 times 5 times 1. We end up with a negative 5. 4 times 2 times 4. That's 8, 16. So 16, that would be x to the power 3. And that's a negative. So basically that's what we have. I'm just hoping we don't have any errors in our calculations. I hope so. This is the power 3. So we have 1 minus x multiplying by 1 minus 1 over 8x. So we've only gotten the first 4 terms in the expansion of the right hand side. Okay, so 1 multiplied by everything remains as it is. So if you use now negative x, what will change is everything will increase by x. So 1 will be negative x. That will be positive 1 over 8x squared. That will be negative 3 over 8x to the power 3. And finally that will be positive 5 over 16 x to the power 4. We're only interested in the first 4 terms. So we'll group them. constant 1 will remain. This part matches up with this part. So that is negative 1 over 8 minus a 1, right? So that would be negative 1 over 8, which if you take it in terms of an improper fraction, 8, 9 over 8. And then x squared, 3 over 8 plus 1 over 8, that's a 4 over 8 x squared. In this part, negative 5 over 16 minus 3, negative 5 over 16 minus 3, no, minus, this part, minus 3 over 8. So that is negative 11 over 16 x to the power 3. These are the first 4 terms. Okay, hopefully our manipulations are right as well in this case. So basically this is the idea on how you are able to, or you should handle these kind of questions. Just apply this formula of the binomial expansions to manipulate the denominators, and then multiply with the other part, just as we multiply the quadratics, the linear functions that we know. Okay, you can either use this kind of addition, or you can use the previous one that is a bit straightforward, where you write the first line on top, other one down, and then arrange according to the powers that you have. Okay, so that's it for this question. Alright, so we'll look at question 3, which is asking us to find the term independent of x in the expansion. So the expansion we're given is x squared minus 1 over x raised to the power 6. So how basically do we handle that? So finding the term independent of x implies we have to find a term which does not have x as a variable. Alright, so we already understand the fact to say if you're going to have a binomial in this form, let's call it a plus x raised to the power n. We understand to say to find any term of that expansion, we can use a formula where you can say n and then r. You have, those are the coefficients, and then you're going to have a to the power n minus r, and then of course x to the power r. That's what it implies. So if they ask you to find, let's say, the second term, since we know that we start counting from 0, if I ask you for a second term, it implies it will be the term that is having n choose 1. Okay, now in this case we don't have a term that we're dealing with, so we'll just apply the same formula. Okay, now what is our n in this case? Our n is the power 6, so we'll say what we're dealing with is 6, choose what we don't know, and then we'll say our a is x squared, which would be raised to the difference between the power, the highest power, which is 6 minus r, which we don't know, and then x in this case is negative 1 over x raised to the power r, since we don't know what r is in this case. Okay, so I can remove this part and then show that this is basically what we're interested in. So let's try to find the power, or let's try to simplify this. So here what we know is 2 is going to multiply with whatever is outside there, so that would be 2 multiplied by 6 minus r. So for basically for us to have no x, it implies the power of the x on top and the one down should be equivalent. And of course we understand that if I were to distribute the r there, x would become the power r and 1 to the power r, but 1, even if we raise it to the power r, nothing will change, so it will just be x to the power r. So the power of x, which is r, should be equal to the power of x on top, which is 2 multiplied by 6 minus r. So I'll just equate the two. Okay, now we're going to have 2 times 6 is 12 minus 2r is equal to r. We have 12 and then r plus 2r, which gives us 12, 3 r, and then our r becomes a 4. So our r is 4. Okay, what term is that? Since we start from 0, that is like the 5th term. Okay, so these are the possible solutions. Can we prove this? Well, we can. That is x squared. Now we found our r to be 4. So it implies if we put a 4 there, it means even there it's going to be 6 minus 4. And then we have got negative 1 over x. This is now also raised to the power 4. Is it? Is it the power 4? Yes, r is equal to 4, so what it means 6 minus 4. Okay, let's go. So the next step, we're going to have 6, 4. And then 6 minus 4 is 2. 2 times 2. That gives us 6 to the power 4. And then we've got negative 1x to the power 4. If we were to distribute the power, negative 1 times raised to the positive power to an even power gives us a positive 1. And then over x to the power 4. So you can clearly see that these are going to divide. And hence, this clearly proves that to say this term is going to be independent of x. Okay, so apply the same concept to answer this one. Alright, so I'll just go direct the point since we already know what to do here. So we use our formula n. Our n in this case is 8. So 8 r, and then we've got 3x, which should be raised to the power 8 minus r, and then we also have negative 2 over x, which should be raised to the power r. Okay, we know where we formula where this is coming from, right? I've already indicated to say nr. If you have a, it will be n, and then the other one would be, you just fit the power r, and that's exactly what we've just done. Of course, this is in a case where you have a plus b raised to the power n. This is how you find the term in the binomial expansion. So feel free to pause the video and just try this one out. So of course we're interested in the power of x, so that's going to be the power of x. So that will be x is to the power 8 minus r, and then for this part that will just be x to the power r. So if we distribute, we equate the powers now. 8r being equal to r, 8 is equal to 2r, and then our r also becomes 4 in this case. So equally r is equal to 4. Okay, you can prove if you want. Same question is repeated. So here we have 8, choose r, and then we have 2x in the brackets raised to the power 8 minus r, and then negative 3 over x to the power 3 raised to the power r. Feel free to pause the video and try this one out. So for this part, x will be raised to the power 8 minus r. The other part, it will be this 3 times that r, so that will be x to the power 3r. So that's going to be 8 minus r is equal to 8r, and then 8 is equal to 3r plus r there, and then that gives us 8 is equal to 4r, and then r becomes a 2. So therefore, it's r is equal to 4, which we can call the 5th term. Simple and straight. No, actually r is equal to 2, which can be called now the 3rd term. Okay. So this is basically very simple and straightforward, right? Just understand that when they say the term independent of x, it implies a term that doesn't have x variable in the expansion. And of course that occurs when you've got a variable on top and on bottom. And so at the point where their powers are going to be equal, they will divide. Okay, let's look at question 6. This is very simple and straightforward. We'll just get into it. So we want to show that the left is equal to the right hand side. So I'll start with the first one. So we have n0 plus n1 plus n2. So I've been looking at these questions and it's taken me weeks. I just look at them. I don't know how to handle them, and but today I just sat down and said, let me try to answer them, and then I just discovered this is very simple, and I thought it is. Yeah. So even in exams, when just because you've never seen a question doesn't mean that you can't solve it. Okay. So I don't know how to manipulate the left hand side, but let me manipulate something that looks easier. Since we are dealing with binomial expansions, I can express 2 in terms of addition. So our right hand side is equal to 2n. Now 2n is the same as what? 1 plus 1, right? Raise the power n. Let's try to use the binomial expansion to expand that. So our right hand side becomes, we know the first part will be n choose 0, and then to be 1, n minus 0. Remember, we're still using the same formula, that is, if you're going to have a plus b raised to the power n, okay, the formula is, for any term it's n choose r, and then you understand that a will be the difference and then b will be to just the power r. So that's what we're trying to do there. So n minus 0, 1 to the power 0 plus n choose 1, 1 n minus 1, 1 to the power 1, n choose 2, 1 n minus 2, 1 to the power 2, plus dot dot. The final term, which is n choose n, is going to be 1 raised to the power n minus n, and then that will be 1 raised to the power n. So you know that is 1's raised to any powers, they still remain 1's, right? Okay, so this will just mean that we're going to remain with n choose 0 plus n choose 1 plus n choose 2 plus, until we get to the last term, which is n choose n. So we can now see that the left hand side has become equal to the right hand side. So left hand side is equal to right hand side, hence shown. Now with the basics that I've given you, you are now at liberty of looking at the last one. Yeah. So now the last one is dealing with a bit of some subtraction here and there, and so we can just edit this one slightly. There is a negative, there is a plus as it is, and so what we have is a minus, an addition, a minus, again a minus, 0. This one I didn't even try it on paper. This is, I was just trying to think of it as, I'm hoping it works out the same way that the first one was worked out. So feel free to pause the video and try it out. I can give you a hint. When you've got a 0, think of it as expressing it in terms of an addition, in terms of binomial. 0 can be expressed as 1 minus 1, right? So our right hand side is equal to 0. 0 is the same as 1 minus 1. Now I'll bring back the power n, right? Okay. So what does that, how does that come out? How does it come out? So if we try to proceed in the next step, we'll see n choose 0, and then the first part will be 1 will be raised to the power n minus 0, and then the other part, which is now negative 1, as we can see from the expansion there, negative 1 will be raised to the power 0 as well, plus n choose 1, and then 1 raised to the power n minus 1, negative 1 raised to the power 1, plus n choose 2, 1 n minus 2, negative 1 raised to the power 2. Now you know that any time or every time that you raise a negative to an even power, the answer is always a positive, right? And so we understand that is going to give us a positive, and then essentially after that positive there, the next part is going to be an odd, which will be a negative, and that's where that dot is coming from, and that will continue exchanging until we get to the last one. Okay, so obviously that's what we expect. And then n choose n, you're going to look at that, it's going to be 1 n minus 0, and then here you understand that for the last one where we have negative 1, now in fact that's not n minus 0 it will be n minus n for the last one, n minus n, and then you have a negative 1, which is going to be just the power n. Now of course the last one is dependent on the value of n that you're dealing with. It's an even power, odd, that will determine the sign, but we'll just assume or it remain the way it is, in other terms. So what we have at this point, you can see for the first part, again we've already emphasized to say 1 raised to any power, it just remains a 1, but now the negative in this case is playing a different role. So negative 1 raised to the power 0, now that is a positive, you have to be careful there. So that would be n0. For the second one now, where negative 1 is raised to the power 1, that clearly gives us a negative, and then n choose 1. Then this one, negative 1 is raised to the power 2, so that gives us a positive n2. Now the next number, obviously after the third term, is going to be a 3, which is of course an odd number, and a negative 1 raised to that number, we are going to get a negative, and this will continue swapping. That's what this implies, negative dot dot negative, and then n choose n. So now you can see that the right hand side equally in this case is equal to the left hand side. And so that's it for question 6. Very easy to show. Just try to understand what's given on either the right and the left, and which one are you able to manipulate easily. That will help you make a decision on what you need to focus on.